Here is a sample problem on two-dimensional collisions. A 1,300 kilogram car traveling north at 30 meters per second collides with a 2,000 kilogram car moving east at 15 meters per second. As a result of the collision, they stick together. What is their velocity after the collision? Here are the steps which we will follow. First, draw a pictorial representation before and after the collision. Then, part B, draw a momentum diagram and solve the conservation of momentum equation in the x direction. Part C, draw a momentum diagram and solve the conservation of momentum equation in the y direction. Then, find the resultant velocity. And finally, find the total initial and final energies. Here are some questions to ask yourself. Is kinetic energy conserved in this collision? How do you know? Where did the energy go? What type of collision is this? So first, we draw our x and y axes, and then we show the directions on our axis. So we have north, south, east, and west. And then we draw the cars initially and at the end. So let's draw, we have a 1,300 kilogram car traveling north at 30 meters per second. So let's draw it on here. There it is. The V1 initial equals 30 meters per second. And mass 1 is 1,300 kilograms. And then we have our other car. It is car 2. And we have V2 initial equals 15 meters per second. And mass 2 is 2,000 kilograms. So these two cars are going to come together and they're going to have a collision. And after the collision, they're going to stick together. And they're going to move off. Let's look at the initial momentum here. What is the direction of the initial momentum of the two cars? So remember, P initial equals P1 initial plus P2 initial. So what do you think is the direction of that?
It's northeast.
Northeast, right? We have to add these two vectors. So the initial momentum is sort of in this direction, roughly. Because this vector plus this vector gives us this. So we expect the final momentum to be in the same direction as the initial momentum, because momentum is conserved. So when the cars stick together, I'm going to show them here, they're going to be moving off roughly towards the northeast. So here's two cars. They're stuck together. And they're moving off like this. And that is V final, which we don't know. And the mass here is M1 plus M2, which is 3,300 kilograms. And this thing is coming off here. So there's some angle theta that we don't know of yet. So that is the first part A. The pictorial representation before and after the collision. Now let's look at part B. Draw a momentum diagram and solve the conservation of momentum equation in the x direction. So let's draw that momentum diagram in the x direction. So we have something like this. This is P1 initial in the, I'm sorry, it's going to be P2. P2 initial in the X direction, because there's only one car moving in the X direction. It's just car 2. So I'm only going to put car 1 momentum. And this thing must equal P final in the X direction. So I'm going to draw a momentum diagram for these two things. So P1, so this is going to be V2 initial, and this is going to be V final in the X direction. And this is V final in the X direction. And this is mass, and this is mass. So let's look. So car 2 has a mass of 2,000 kilograms. So I would say, so this is about 2,000 kilograms. That width is 2,000 kilograms. Its speed is 15 meters per second. So I'll go up here, and they'll say that's 15 meters per second. And this width is 2,000 kilograms. So this is this area represents the initial momentum in the X direction. Now let's look at the final momentum in the X direction. It has to be equal to the initial because momentum is conserved. But the width here is larger than 2,000. It's 3,300. Because the mass is larger after the collision. So that means the height here cannot be 15. It's going to have to be less than 15. So maybe it's like that. And this is V final X. And it's less than 15. So this area equals this area. So now let's solve the problem. We have this, P2 initial X equals P final X. So let's write that down. P2 initial X is M2 B2 initial. And then P final X is M1 plus M2 V final. Now we put in the numbers. So we have 2,000 times 15 equals, so M1 is 1,300. So it's 1,300 plus 2,000 times V final. So this thing here is 3,300. So we should just divide by 3,300, both sides. 3,300. And then these are going to cancel. So we get V final is 2,000 times 15 over 3,300. V final. 2,000 times 15 over 3,300. And that is 9.09. So, and this is V final X. So we have V final X is 9.09 meters per second. So now we will find we will solve the momentum equation in the Y direction. First, we will draw the momentum diagrams for the Y direction. Let's do it over here. I'll take out this. So this is still the south. So let's put it here. Do it. Good. So we're going to have P initial, which is really P initial 1, or P1 initial in the Y, because that's the only initial momentum in the Y direction. And that's going to equal P final in the Y direction. So we can draw the momentum diagrams. So this is going to be V1 initial Y. This is going to be V final Y. And this is mass and mass. So we start here. 1,300 kilograms. So let's draw the mass say that's 1,300 kilograms at width. And it's going 30 meters per second. So let's go up here. We'll say that is 30 meters per second. And this width is 1,300 kilograms. And then the final mass is 3,300. So we got something much larger here. Let's say it's like that. This is 3,300 kilograms. So we got a larger width. The areas have to be equal. Since the width is larger, the height is going to have to be smaller. So let's say it's something like this. And this is the final y. That's what we're trying to find. So these two areas are equal. Now we can write the conservation of momentum equation. So P1 initial y, we're going to have M1, V1 initial, because it's all in the y direction, equals M1 plus M2, the V final in the y. Then we put in our numbers. So we have 1,300 times 30. 1,300 times 30. M1 plus M2 is 3,300. This equals 3,300 times V final y. So V final y is 1,300 times 30 over 3,300. And that is going to be 11.82 meters per second. So that's our answer for V final y. V final y. This is V final x. So answer to B and to C. Next is to find the resultant velocity. So, does anyone know how to find the resultant velocity? Put it in the chat if you were able to, if you know how one goes about finding the resultant velocity. Pythagorean, yes, Pythagorean theorem, trigonometry. We need to go back to, we got even an answer, 14.9 meters per second. That is the correct answer. We need to go back to what we learned in kinematics. We have the x and y components of the velocity. And we need to find the resultant of that velocity. The addition of the two components gives us the resultant velocity. So let's see how we do that. Let me draw a triangle. I'm going to draw a triangle over here. So this one is V final x. V final x is 9.09. And then we're going to draw V final y going upwards. So this is this. V final y, which equals 11.82. Of course, this is a right angle triangle. So this vector plus this vector gives us the resultant, because V final equals V final x plus V final y. So this is vector addition. Let me draw V final x. We're adding the two vectors, so we go from here up to there. So that is V final. Okay, these are vectors. So that's what we have. And this angle, that's theta. It's the same theta. So if we want to get V final, we just use Pythagorean theorem. So let me show you that. I'll show it over here. So V final squared is v final x squared plus v final y squared. Pythagorean theorem. Take the square root of both sides, right? Square root. Square root of v final squared is just v final. So v final equals square root v final x squared plus v final y squared, which is square root of 9.09 squared plus 11.82 squared. And that thing is 14.9 meters per second. So that's how we find the magnitude of the resultant velocity. But we also need the direction. Velocity is a vector. We need a magnitude and a direction. So let's find the direction. We can just find this angle theta. So how can we get theta? Trigonometry. Tan theta. Let's do it over here. Tan theta is opposite over adjacent, which is v final y over v final x, which is 11.82 over 9.09. So that's tan theta. So then what is theta? Theta is tan inverse of that. So you just put that in your calculator. So theta equals tan inverse of 11.82 over 9.09. And you work that out, you should get, make sure your calculator is in degrees, or else your result will be in radians. You should get 52.4 degrees. Yes, people are getting it. 52.4 degrees. So 52.4 degrees. So we can then specify the final velocity. We can do this. So v final equals 14.9 meters per second, and then the direction. We can say east 52.4 degrees north. East 52.4 degrees north. Or we could say, another way we could say it is 52.4 degrees north of east. So that then is our expression for the resultant velocity. The next step is to find the total initial and final energies. Then we can see whether or not energy is conserved. So you need, for this thing, you need to find the sum of the energies. So find the kinetic energy of car 1 initially, and then add that to the kinetic energy of car 2 initially. And that will be your initial energy. And the final energy, you take 1/2 the total mass times v final squared. So work out those two energies. I'll give you a few minutes to try that. I will now show you how to find the total initial and final energies. Let's see where we can do this. I'm going to have to erase something. So I hope you don't mind. I'll erase this. I need some space. Okay, so the initial energy is just the kinetic energy of each of the cars. So kinetic energy initial equals kinetic of 1 initial plus kinetic of 2 initial, which is 1/2 m1 v1 initial squared plus 1/2 m2 V2 initial squared. So it's 1/2. So 1,300 kilograms times 30 squared. Plus 1/2, 2,000 kilograms times 15 squared. So that's what we have. Now you work that out, and you should get 810,000 joules. So that's the initial energy. Now let's look at the final energy. We'll get rid of this. A final is just going to be 1/2 m final v final squared, which is 1/2. M final is the sum of the two masses, 3,300. 3,300 times 14.9 squared. And that gives us 367,000 joules. So we look at this. Is energy conserved in this collision? Energy is not conserved. That's right. So energy was lost in this collision. And where did that energy go? What happened to the energy that was lost? What did it become? It became heat. Did it become anything else? It became friction. Yeah, there's some friction. What about the cars? Do you think the cars were damaged in this collision? Yes, the cars were damaged. So there were dents in the car. So it takes energy to create those dents in the car. So some of the energy went into the work to create the dents in the cars. So what type of collision is this? This is an inelastic collision. And we could say it's a completely inelastic collision because the two objects stuck together when they collided. So that's completely inelastic. And the maximum amount of energy was lost. Okay, that's the end of this. Does anyone have any questions on this?